Good morning again. Thank you very much, a student and everybody who take the initiative to follow this link and to study chemistry online. I know that many students are staying home and they have nostalgia. They need to return back and to be in front of the teacher. But you are not alone. The distance is not the problem. I have prepared the lesson. Now, even though it is not easy to enter in the laboratory, but we can analyze the experiment, examine what we did at school, and we can relate on what we found at home. But there is a hope. Now, I want that to show you how you can know the partition coefficient between two solvents when the amount of solute is not known and the amount of solute is determined by the titration. For redox titration here, most example is the way of extracting iodine, but the amount of iodine is not known. First of all, if you have you wanted to extract iodine, you know that iodine is the reducing agent. It can play the role of oxidizing the reagent, which is colorless, called sodium thiosulfate. Then it means that when you have iodine and you have 2 moles of 1 mole of iodine, we need 2 moles of sodium thiosulfate. Sodium thiosulfate. This sodium thiosulfate, it can be oxidized to give, first of all, you can have a 2 iodide, means that iodine in this way, because you use iodine in the solution, aqueous iodine and aqueous sodium thiosulfate, aqueous, and here we can have also, you find that you have sodium persulfate and sulfite. Here we have 6, and here we have also 2 sodium, and 2 sodium ion will help us to accommodate the anion, to accommodate those iodide. Dear student and dear learners and dear people who are following this ring, when we are titrating, it means that number of mole of iodine is equal to the number of mole of thiosulfate over 2. It means that when we find the number of mole of iodine, it means that redox titration is done in organic phase, and also redox can be done in redox titration is done in aqueous phase. And we know that by experiment we can take, first of all we can have, by using separating funnel, we have 2 phases. There is org and there is also aqueous. After separating, the organic phase is here and the aqueous is away and organic is away. In this case, it means that we start titration. In this titration, both sides will be titrated by using, here you can use burette, by using potassium, sodium thiosulfate. And you know that in every time you are titrating, you can use a starch solution. And after knowing the amount, you can take the concentration in org, the concentration of iodine in org over concentration of iodine in aqueous, and exactly you are able to determine distribution coefficient at that moment. Because the amount is not known, you must know that concentration of iodine in org is equal to number of mole of iodine of volume of organic solvent, but also it is equal to initial number of mole. It is equal to x over volume of organic, because x is equal to the iodine transferred in organic phase. I hope that you must understand whether it is important to know the amount of iodine or another solute which can be transferred from a solvent to another by equilibrium. If it is not known, you must know the reagent which must be used for determination of the amount needed in order to calculate distribution or partition coefficient. Thank you very much indeed.